Hello and welcome to Practically Clojure with me, John Stevenson. Thank you very much for joining me. So I'm going to do a specific project using CircleCI and Clojure CLI tools deps, and I'm going to build a random Clojure function generator. So it's going to show the name of a random function along with its signature and the description. So I'm going to walk through that and using CircleCI just to run our tests as we write them. So if we go to a Practically Clojure website, there is the Practically Clojure book. I'll click on that image, and then inside the testing Clojure, there's a way to set up the CircleCI random Clojure function project. So this is what we're going to walk through. We're going to create a new project using this random function guide, add it to GitHub, add it to CircleCI, add our configuration, and then start developing the project. So I'm going to walk through also the development of that particular project to generate the random Clojure functions. Ooh, that doesn't find the page. Oh, that's not right. I've broken the link, sorry, there we go. Oh, that's not right at all. Yes. Oh, there we go. Where is it? So the project itself is simple projects, random function. So that's what we're going to walk through how we're doing that. So we're going to create a new project here, and there we go. Oh, what we're doing. Oops, nope. We create a new project, just a Clojure deps project. There we go. Yeah. And I'm going to go in and edit that project. Yeah, I'm using Spacemacs for doing this. Any Clojure editor will do. So space FF to go and open the project, Clojure projects, Clojure random, what do they call it? There it is. So this is the structure, so I'm going to open the deps.edn file. So this is very straightforward, just using the standard source and resources directory. I'm not actually going to include anything in the resources. We've got Clojure 1.10.1 as the main dependencies, and the aliases. By default, we've got the test, which includes the test path. I'm not going to use Clojure check in this respect because I don't have any specifications. We've got runner to run the Cognitect text runner, and just formatting this into so it's consistent. And then we've got uberjar if I do need to build the project. Again, I don't think I'm going to use that at the moment. I might use it at the end. And then we've got our source files. We're going to source Practicalli. That's our main function. Doesn't do a whole lot yet. And we've got our test files here. I could run a REPL locally. We're going to use jackin, but I'm going to use I'm going to include the test alias here as well, so it'll pick up my test path. So if I just add a :test, then that will make sure that these def tests are included in the class path, and I can run them from within Cider. This is something that I'll add when I run this on the command line. It just takes a second to run. Then I can run TA will run load and test, and it fails because 0 is not equal to 1. So it's all working quite nicely. So we can start developing, but before we start actually writing out the project, I'm going to wire it up to CircleCI. Oops, wrong button. So if we go back to the integration testing, random Clojure function, and then we can set up a remote repository to do this. So if we go to GitHub, Practicalli, and here create a new repository. I've cleaned out all the old ones there, so it should have random Clojure function. There we go. And we're going to create that in the Practicalli repository. Practicalli organization, and the repository is random Clojure function. I'm going to make that public. It doesn't generate shows. There we go. I'm not going to add a license or anything like that. So that's going to be part of the what I get from the local repository. Create that. Grab the URL for this repository, and then go back to my editor. I'm going to create a local repository, local Git repository, just using the using the Maggot client. Oh, that's not right. Oops. Too bad. I created it in the wrong directory. Sorry. X is not there. Oops. I created that in the test directory. No, that's not. Let's try that again. Git. There we go. So go back to editor. Oops. Yep, this is not there. So let's create that in the proper place. Git initiate. There we go. So create that in the root of the random Clojure function. There we go. Stage the git ignore. No, I don't want to trash it. No, stage it. I'm not going to use that license. I want the deps file. Don't need the POM just yet. I'm going to add the source and test. And then we're going to commit new project. Start Eden. No, that's not it. I like to include the actual command used when I create the project, just to make it nice and clear how the project was created, what tools we used. Am I doing that in the right wrong place? There we go. Let's just like that. There we go. That way it's always known what was used to create the project. Oh. Yeah. Butterfingers now. And then we just commit that. And we can add the space Shift M. I can add the remote. I'm going to call it Practicalli, so I know which organization it's from. If we go back to here, copy the URL. And then wire it up. I'm going to set that as the default place to push things to. CI is not going to work if you don't push the code to the right repository. And then I can just use P and push to the Practicalli live repository. This is using, when I create the Git, when I initialize a local Git repository, it defaults to using the name live for the branch rather than master. I think it just is more meaningful that way, because this is the code that's going to be used for live, and then any other branches like develop, I can build off live anyway. And there we go. So we go back to here, our code should be up on the project. There it is. I should add a README to that as well. And I can go to CircleCI, go to the app, go to the dashboard. I'm already logged in, so it's not asking me to log in again. This is a JRocket organization, so I want the Practicalli organization, and I want to add a project because these are the projects I've already got. I want to add a new project, and then there it is. It's right there at the top. So set up the project. Before I do that, I'm going to go and add a CircleCI configuration. Rather than using the one that they suggest, I'm going to use this one, which is specifically for Clojure OpenJDK 11 and tools deps, which is what I'm using locally. So if I do I should type this in, it's quicker. There we go. If we do Clojure sdescribe, it'll show me what I've got installed locally. So we've got here, we've got the version of the install, so specifically version 536, which is the latest version according to the Clojure.org website. So that's the image, the Docker image I'm going to use to run whatever tasks, whatever steps I want CircleCI to run. It's going to run within that environment, which is the same environment as I have locally, because I'm pretty sure I'm still on Java 11 version. I'm on Java 8, so let's change that. Alternatives. I'm going to choose 0 for Java 11. Again, yeah. So we've got Java 11, and we've got the same version of Clojure as well. So if we copy this. It's going to check out my code. It's going to create a cache that's for the dependencies. So when we run Clojure test runner here, so this is downloading the dependencies. It's going to put them into the cache. And we've got two paths. So Maven libraries are going to go into .m2, and anything we pull from GitLab, anything we pull from Git is going to go into GitLabs. And then once that's all done, we'll just run our tests for now. So if we go in here and add a file, we do that to the root, we do add a CircleCI/config.yaml. We paste that in, save it, create the directory. So that's all part of our project now. So it's in CircleCI.config YAML. So we're good. So now we can go back to CircleCI and we can go in and set up a project. Oh, actually, let's push that to Git first. So go space.js will go into my Git client. And you can see we've now got this CircleCI directory. So if I stage that, it's going to stage the directory and the file within inside that directory. Do commit and call so we can see it's just adding the YAML file, confirm the commit message, and then we just push that up to GitHub. Boom, there we go. And so if we go to our Git repository, we just refresh this. So 42 seconds ago, we created this CircleCI repository with our YAML file in there. So that's good. So we don't need CircleCI to create anything. We can just basically wire it up to the, it's already got the configuration in the repository. So when we set up the project, we don't need to add a configuration. We can just add manually. We've already got our config, so we just start build. And it should take us to the build pipeline, and it's running. So this pipeline section is basically running all the builds for this particular project. We can go in and select all the pipelines. So here we're just doing it for a particular project. We can look at all projects as well. So if you've got, so you wanted like a dashboard of what's actually working, you could have a monitor somewhere that's shared in a team room where you're all just running. Have this display running, and you can see what are the active projects. And whether they're running, what's failed, and what's passed, and it's failed. So if we go back to this particular function, oops, wrong. And so we can see we're on the live branch, and we see it taking 39 seconds to run. So this first one probably takes a little bit longer because it's building up a particular cache of the dependencies. So the first time it runs, it will need to download all the dependencies. So this test run will be probably slightly slower than other ones, especially if you've got a lot of dependencies in your project. And we can see that the build has failed, so we can see which steps have passed. So everything's passed up until running the tests. And we see it's running the test in the test directory. It's running the right namespace, but we can see actually it's the test itself that's failing, and not the test runner. So that's correct because our tests are failing locally. So we can just fix our tests and it should run. We go back to the editor. We go back to our test. If we fix this text one, I'm actually going to just replace this test altogether later on as we build the application up, but just to make sure that the tests are actually working correctly, let's save that. Let's run the test locally. I'm going to use the test alias and the runner. So this is the test alias and runner alias that's configured in the local deps file that we've got. So this is going to set the test directory to be included. Did I run that from the wrong? I'm not paying attention. Oh yes, I run that from the wrong place. Yes, excuse me. Oh yeah, there we go. That helps if you run the. You need to run the application you need to run Clojure from the right directory. So this is where the deps.edn file is. So if we look at the deps.edn file again, you see we've got test, which is just adding this test to the class path, and runner, which is just going to run Cognitech tests. So if we run it here in the right place, now our test should pass. So we've got 0 failures, 0 errors. That's good. If we go back to our editor and we go and commit our change to our template test. and then we've just pushed that, and then we can see whether CircleCI is actually picking up our tests and whether we're actually pushing it to the right location. If you push it to the wrong repository, then it's obviously not going to detect it. But here we're running, and you see that the commit, it's showing us the commit message from the latest commit that's triggering it. If you push multiple commits, then at the same time, so you might commit several things locally and then do a push. It'll show you the message from the most recent commit there as well. So this is going to run every time you push the commits to GitHub. It's got a little hook there that will run that, and it should. It's taking a bit longer this time. How unusual. And success. So it's actually passed this time, which is good. So it's picking up the changes that we're pushing, and when we run the tests, it's actually we're not getting any errors. So that's a good sign. So now we can actually get back and we can just leave this setup and just get on with just developing our application. So let's switch back to the simple test here. So in simple projects, random function, this is what we're going to build out now. And then in the background, CircleCI will just be running all the tests that we want as well. So we have some security that everything is working together. So when I was thinking of ideas to do this, then one of the things that popped into my head is just having a little program that just generates a function name from the 600 odd plus functions that are out there in Clojure, in the Clojure core. But also there's several other libraries that make up what I tend to refer as the standard library. So we're going to pull some of those out there and get the descriptions. It's kind of like a nice kind of flashcard way of learning a function just by kind of randomly kind of having functions appear. So actually to get a list of the functions available, it's fairly straightforward. There's a function called nspublics, and if we give it a namespace, it's going to return kind of like all the public functions available in that namespace. And then we can just do vals on that and get the specific kind of values for each of those functions. So let's have a look at that. Boop. So we go to our code and let's quit Git. And we've got our REPL running already. Oh, it's running Java, right? I'm going to quit that REPL. Boom, boom. Will it pick this up? Yes, it should pick this up because this is using the Clojure. It's going to call Clojure on the command line, and I'm going to give it -a test to pick up my tests. And this should fires up the REPL on the outside of Emacs and then connects to it, so we can basically send Clojure code to the REPL and have it evaluated for us. So if we look at these functions, let's put this as REPL experiments for now. There we go. Oop, yeah. So we can evaluate. There's nothing I've added to the namespace yet. I'm just doing some experiments just to see what this code does. So if you've got nspublics, so it's returning a big chunk of information there, and somewhere inside this map of information, there's a specific information we want. But if we go and get just the values, so rather than the keys, we want the values from this. Then you can see actually it's pulling out Clojure Core primitive class names, Clojure Core plus decimal. So we can see it's got function names that are from Clojure Core, and it's got the it's also got the domain that they're from as well. So they're all from Clojure Core, so they all start with Clojure Core. So that gives us a pretty quick way to get the list of Clojure names. If we get a random version from that, a random nth from that, then we can see, yeah, we just got the Clojure, a random Clojure name, a random Clojure function. So that's pretty easy to do. But it's just giving us the name, so we actually want some more information, because we could have this name and then you can guess what it does, or go and look it up, or we can actually just get some metadata around it as well. So let's grab this rand nth. It's got these standard library functions, because I think that's what I was going to put create a def for that as well. So let's do that. Oh, that was working before. What's happening? Which bit's not working? That's working. So I'm just evaluating I'm just using evaluate last expression just to evaluate the nested values. Run nth is working. For some reason meta is not working. Why is that not working anymore? That was working. Let's see. Where's the one I did earlier? There we go. Oh, no, that's not. Oh, there it goes. That's the one I was looking for. Oh, yes, sorry. Yes. Yeah, there we go. So oh yeah. So I can't do, oh, why is it not working then? Function lists. So I can get so here I've done some defs to get the Clojure core. And here I've got the available namespaces with just a concatenation of all the all the namespaces that we can get. So we can get all the namespaces from Clojure that's in the current kind of REPL namespace. Yes. So evaluate that. Oops, why is that not working? Oh, it takes a while. Oh, it's not working. Come back in a second. So we get all the namespaces here. So it's not just Clojure core, but it's also Clojure. It's like Cider REPL. So this is pulling out the Cider REPL ones as well, because I'm running it in a Cider environment, which is what Emacs uses. Cider is the package that connects to Clojure in Emacs. But if I run this, run all ns in the kind of just running Clojure on the command line, then it would just include that. So all ns gets all of the namespaces from everything that's currently in the REPL, and Cider is adding extra things to that as well. But we can just get specific. If we just define specific namespace, then we can get those as well. So we could like rule out particular namespaces from that. Why is it meta not working? Okay, yeah, so let's start by just using this. Define a standard library function, just using Clojure core. So I'm going to put this in at the top here. Evaluate that. So if we do standard library functions and just evaluate that, then that's our list. So this is returning a sequence of all the function names, and so that's working quite nicely. And then then we can start writing some unit tests around here as well. So we edit the random core function CLJ test. So we go into our test file and basically just add this test function. And at the moment we're just testing main for the project. So if we save that. Let's go to the test class. So test namespace, sorry, not Java. I'm going to delete this test, but I'm first going to unevaluate this because I don't want a test to be in my REPL. So I'm removing that from the REPL itself, and I can remove the code, and then it's not going to trying to rerun that test because it's still in the memory of the REPL. That's the approach that the editor takes. So just make sure that it's not running kind of ghost tests. We got dev tests. So this is testing. It's testing the showing function from the whatever we define as the Clojure standard library. So I'm going to update this a little bit. I don't like reusing refer all. I'm going to use def test is and testing. Those are the three functions I'm directly using from Clojure test. And as the Clojure test is the main focus of this, then that's a good approach just to include the function names. You don't need a particular alias. And for the namespace I'm actually testing with this test namespace, I'm going to just do that as an alias, and I'm going to use the standard system under test alias, and so then I can very easily see which of the functions and vars I'm actually using and testing from the namespace, the main namespace I've got here. So at the moment I'm just going to check to see whether the standard library functions are returning a sequence, and does main return a string, because I want a string of the function name and then a string of the function name with the details of that function at some point as well. So run that. Ooh. What's he complaining about? Notice files main. Oh yeah, so evaluate the updated namespace. Oh, I haven't evaluated this namespace, so it doesn't know it's there yet. There we go. So the test runner inside my editor is only going to evaluate what it knows about. It doesn't know about these things yet. So evaluate those, and it should be able to pick them up. There we go. Run the tests. It's got one failure because at the moment we're not actually returning the string from that. So we're not actually getting anything back from the main function yet. You see it's printing out a string which is going to send that to the standard out rather than returning it as a value. So it's only going to return nil as a value. So we need to change that at the moment. So we change it to a string, then we can see it all runs, but that's not the string we want. So we need to do something with our vowels. So this is our updated main function. Let's just grab the whole thing. Boop. Did that. So what it's doing is it's going to get the standard library functions, which is this nspublic's vowels. It's a list of all the Clojure core things. And then we're going to get a random one from that and then call meta on that as well. What's that doing? Oops. There we go. So that's compiling. What happens if we call this? So if we just call main dash main. And we don't need to give it any arguments at the moment, so we got any number of arguments as the argument list. Again, if we're going to call this on the command line, we might be passing in arguments. We might pass in 0 or 1 arguments. The arguments we're going to pass in later on are probably going to be the specific namespaces we want to get a function from. And so we've got a let binding in here. It's just binds function details to the result of calling meta on randinth of standard libraries. We're using a let basically because we're using function details in a couple of places. Because meta should return a map and of all the details of that function. One of the details is the function name, and another one is the actual stock string that comes with that as well. I'm just separating it with a return character so that the function details is shown on the next line, and we return that with string at the moment, so we actually have something that our tests will pick up on. So we save that, evaluate that, and do our tests still run? Yay, they still run. It's complaining about some other code. Yeah, this code here. Not quite sure why that's not working. Whoops. There we go. And so if we call main, is that going to work? There we go. So that's working. So we've got a function called doRun, and it's going to, and that's the doc string for doRun. So if we evaluate this over and over again, we get the names. Oh, you see, find function implementation does not have a doc string, and so that's depreciated as well. So we could also look for depreciate functions in here as well by adding some code to check for that string in the doc string. So that's working. And if we run this on the command line, hopefully it should work. So if we look at the README file for this, oops, there we go. README. It does include how to actually run the command on the command line, run the application. So we basically just run Clojure and we tell it what the main namespace is, and in this case it's the namespace. There is only one namespace in there, so it's going to run that, and it's going to look for a dash main function in there, and if it finds it, it's going to run that function. So if we go to our command line, boom, and run that, and so it's not printed anything out. That's because we're using string rather than print line. So at the moment we don't have a viable command line application yet, but it is working inside our editor. You can see we're using string at the moment, but if we want to print it out as a command line, then we'd change that to print line. So we can run the tests as well. We can run the tests locally to see if they work. So again, we're using, so you can either use the aliases I've got in my .clojure deps.edn file. I've got a test path and a test runner cognitect. Or you can use the tests from use the aliases defined in the local deps file. So I can also do Clojure test and runner, because those are the ones defined in the deps.edn file. There. By the way, we're running one test with 2 assertions, and we don't have any failures, so that's good. We can push that to our code, push that up to GitHub and have our unit test run. I'm going to add a comment block here, and then put all these REPL experiments in the comment box. That way they're not running. I'm not trying to be compiled or run when we compile the application. These will only now run when I can manually evaluate them in my editor. Oops, what are they doing? Where's it gone? Purple. There we go. So we do git status, and then it's got my changes. I was going to stage the changes. I can't type anymore. Boom. Boom. There we go. And if I push that, I go to build. Let's go back to random functions. So it's running another build, and it's showing me the commit message. And let's see if it runs any quicker. I don't need to sit there and watch this. I can get on with developing the code some more. So let's improve the code so we can get it to we need to get it to print out information on the command line, and also want it to include the arg list as well. That would be quite useful. Oh yeah, so there's a couple of issues with our code so far. So main function returns a string and nothing sent to standard out. We could just change that to a print line, but then we've got a lot more code in the main that we want. Really, what we could actually do is just extract the function that generates that finds the random function and put that in its own function, and then just call that function inside a print line inside the main, and so it makes a slightly cleaner design. So if we're going to do that, we can create a random function and then create a test for that as well. So let's create the test first, just so we know what the function is supposed to do. So we switch to our tests, and rather than testing main, we want to test this new function, which is pretty much going to do what this is doing. So we can actually get rid of main test for now. So we're going to only evaluate that. I don't want it to run. When we call random function, we want to pass a particular namespace or set of namespaces that we want it to run. So that makes it less, because the way we got it set up in -main at the moment is quite impure, because we're just basically using the standard library. We're not defining, we're not allowing kind of that choice to come in through the arguments. We've basically got a kind of a side cause, as it's called. So we're actually just hard coding into the function that it's going to pull this def out. And to make it a nice pure function, we actually want to have a function that takes the namespace or list of namespaces that we're actually going to use as an argument. That way it's a lot purer, it's not pulling anything from outside itself, and it's a lot easier to reason with and test and actually understand, because it's all self-contained. So we're going to do that. So that's what we've got with the test. We've redefined what this second test to call a random function with an argument that is the kind of namespaces that we actually want. And it's saying that there isn't a random function test yet, so that's correct. So we go and create that. So go back to the source, and we want a test. Did I define that already? I did. There we go. Let's just see if that's there. So we define that above the main function, because we're going to call it from main. And this is going to take an argument of function list. So it's always going to be a list of should that be function list, or I probably should be, oh yeah, so it's a list of functions. That should be a namespace list, shouldn't it, really? Naming is fun. Oh, I suppose, oh yeah, it's a function list from this namespace. So at some point we also want to control what namespace we're actually going to pull from as well. But for now we're just going to get kind of the metadata for a particular function from this function list, and we're going to pass in the standard library functions, which is essentially a function list. So this is pretty much what we've got in the main, except I've added arg lists as well. I'm going to put the arg lists after there. So just change the order of these. So the arg list is the kind of the signature of that function. There we go. And then we got the document. So we've got the function name on the first line, the arg list on the second line, and I've put that in the wrong place, haven't I? Oops. Oops. There we go. Let's actually edit the location. So we've got a function details, then we do a return, carriage return, and then we do a carriage return. We got the args list as well. That makes it a bit easier to see what we're doing. And that's returning that as a string, so we can test that very easily. So we're just basically creating a string out of these three pieces of information, just structured in a particular way. And then rather than have this code in the main, then we can just simply print out the results of that. Oh, I missed a... let's go to 1. Yeah. So now we're just calling the random function with a specific list of functions, which we get from the standard library. And why is it complaining? There we go. There we go. Just needed to be evaluated. And then, so if we run our tests, there we go. Now that's compiling now, so we can run our tests. Oops. Oh. So our test is still working. Cool. So we refactored it. The test is still working. And I can just basically pull that, push that into Git. Boom. Stage. Nope. So these are changes we're going to push into that. So we've got this random function in the source, and then just an updated test in our test library there. And push that. We didn't actually check to see whether our build had passed the last time. That's a good question. Did it pass? It was. Yes, success. There we go. So that's cool. We probably should have checked that before we did another push. You can see it's got the list of commits. Commits quite handy to kind of see where in the workflow, where in the stage of development the tests are actually run, the pipeline's been triggered. But that's all looking good. So we've got our build going on there. And if somebody did a pull request to the project as well, you'd also get it to run on that particular branch as well, and get it to run our tests. We see, yeah, success. That it's working. Let's go back. What else did we do? And now we can actually run the application on the command line as well. That's not the command line. There it is. Boom. So we're just running, again, we're running Clojure, and we're saying to run the application namespace. So it's going to go into random Clojure function, look for the -main, and hopefully we've got our function. So bound has a signature of, takes in a variable number of arguments, and this is our docstring for it as well. So that's all working quite nicely. Oh, suppress read doesn't have a docstring. Oh dear. Or any arguments. Oh yes, because it's a so this is a piece of data rather than a function. So we could also refine this to filter out things that are not actually functions. Because at the moment we're just basically grabbing everything that's public. So there are some things inside Clojure core that are like symbols or vars that are just basically like constants in there. Yep, so that's all working quite nicely. So we could ship it, and we know our tests work. So we could package this up and deploy it. What else are we going to do? Oh yeah, yeah. So we've added the function signature to that as well, which gives it a bit more meaning. So that's the same kind of information you get in the editor. So if I go into my editor and go into, let's say, dev test, and we ask for help, we get the function name, we get the argument list, and we get whether the and they get the docstring. It's also adding other pieces of information we could consider adding as well. So it's adding that it's a macro and which version of Clojure it's been added into as well. So we could consider adding those to our application as well. And then we could also consider which namespaces should be consulted. I need to tidy this bit up actually. But we can basically get a range of functions from there. So this is where we can use the all. So what have I done here? Let's go back to the one I did earlier. Oops. Oh. Oops. Oh. That one. There we go. That's one. So we've got, I've defined a function list function and a random function. We've got there already. Oh, this we go. Yeah. So I've got this def all namespaces that I've come up with. What? Let's grab those. Does that change anything in there? I don't think I am. No. So rather than just getting Clojure core, then we got, if we use all ns, I'll grab everything from all of the namespaces that are inside the current REPL. And then we can get just the function names or the function details from that. And we just use mapcat because there are lots of functions, lots of namespaces, so we just concatenate the results of each of the function lists that we get from all NS. So let's just look at that a little bit more detail. So if we do all NS, we get all sorts of different namespaces. And then if we do, if we mapcat over that, then we'll get a concatenated, we'll get basically a flat sequence of all of the functions from all of the namespaces in the current REPL. And so then the function list, basically we can specify a namespace. So this is like a little help function. So this is our section. Why is that not working? This is our kind of like data. This is a little help function. And this is our kind of logic. I like to separate these out with little comments, just so as this project, if this project grew to be bigger than one namespace, then it's very easy to just separate out the data and help functions, and maybe even the logic as well, into their own separate namespaces. So we've got these, and we can then also take arguments to as to what namespace we're actually going to pass in as well. And we can also add this namespace. So as we're going to get all the namespaces, we can qualify where the function is coming from. So when we get meta information, we get a map, and one of those keys is namespace, which has the namespace of the function. So then we can add that to our random function, so we can update that random function. Should I copy that? Boom, so let's update that. Paste. So now we've got a string, and the first line is, rather than just the function name, it's the namespace followed by the name, and we just use a slash there as well to make it look like kind of the normal output you would get from that. And then that's all we've changed. So we can run our tests again and see if everything still works. Boom. Yay, that test still works. So even though we've refactored our random function, it's still working. Again, these kind of fairly limited tests, but at least it's kind of covering the basics of that. And then we can update our main function, so we can decide to give it an argument. So if we pass a specific argument, then it'll use that namespace. We use the argument as the namespace it's going to consult. And if we don't get an argument, then it will just use the default, just use everything from there. So if I've added the available namespaces, so we're going to update the main function. So we're just basically putting in a conditional. So we just put this very simple if statement in, because if we pass an argument into main, it's going to create a vector of that argument, or one or more arguments, so we can pass it in multiple namespaces if we wanted to. But if we don't give it an argument, it's going to be kind of an empty sequence. So we can actually check using the seek function on args and saying this is the same as doing empty, but apparently it's more idiomatic to do seek on args as well, because if this is empty, it's going to basically return a falsy value. So if we pass an argument in, it'll do the first line, which uses a random function for the particular argument. It's going to take that. We need to convert that into a symbol first, just so that the logic in this public's namespace is happy. So its public's namespace needs to use a symbol. So basically, we're converting the string argument into a symbol, and then calling ns publics on that, getting the list of functions from that namespace, and then we can basically just use that as our random function list, and it gets a random one from that function list and prints it out. And so we're using mapgetter here again as well, because we might have multiple namespaces. But if we don't provide any arguments, then we'll just use the default available namespaces there as well. So we will save that. Oops, what did I do? Oh, something's broken. What's broken? Function list. Oh, did I not evaluate function list yet? I didn't. There we go. Oh, I didn't evaluate available namespaces. There we go. Whee. So I'm just evaluating the individual expressions, so that's I know that it's actually going to compile. And if we do command line again, oops, wrong command line, there we go. So this should still work if we just run command line without any arguments. It's given us a function that's got a really big namespace. There we go. Oh, Clojure called juxt. So we've got the namespace domain, so the namespace it's coming from, and then the function itself. We've got the syntax for the arguments, and then we've got the docstring. So this is coming from Clojure core, so we know which function we know which library it's coming from, which namespace it's coming from. Most of them are going to come from Clojure core, because there's about 600 or more from Clojure core. If we did this long enough, we'd get one from a different namespace, which it doesn't want to do at the moment. Oh yeah, Clojure string, there we go. So we can see it's generating these random functions from different namespaces, so that's good. And oh, actually, if we did Clojure.string, hopefully that will return something from string. There we go. So now we're just focused just for the namespaces that are just for the functions that are in the Clojure.string namespace. Cool. And if we push that to GitHub, we can run our tests locally, and they're still running. And then we push our changes. We haven't changed the tests, so only really testing at the moment. We're just testing the namespace API. We haven't tested the kind of helper functions that much, because they're just helper functions. If they work through the the main random function, then they're getting tested that way because that random function is calling the helper functions. So we commit. Push that up. And if we go back to CircleCI, we can see it's still building. And it's building with the commit that we just pushed. And that's it. So that's as far as I've got so far with the random function. There's some other ideas too. We could convert this to a web service just by adding HTTP server. We could convert it to a library as well. So if we're going to use it as a service, we'd probably convert this to a library and then use that library within inside like a web application and make this little set of functions more usable in different contexts. What else have I done? Yeah, okay. So I'll do that over. That's a nice kind of little exercise if you want to try it yourself. But I'll also include that in some of the broadcasts that we do later on. That should be. Oh, we're still running. There will be some variation in how long these builds take to run, because obviously it's in a cloud-based environment and it's in a free thing, so there's no guarantee of how fast they will run. But yeah, they'll usually run. Most of them are running pretty quickly, certainly quick enough to be meaningful. And obviously, they're not going to be much slower, even if we had like 100 tests or so. They'll still be pretty quick because most of the time is spent setting up the firing up the Docker image, and so that's most of the time that's spent, and sometimes that can be a little bit slower. You can see we can develop with CircleCI running to basically have our back to basically make sure that all the tests are run all the time, and whenever we commit or whenever we share our commits with GitHub. And so if somebody does try and check in some code to GitHub and that it's not working, then we can certainly detect that and then fix it while we're still aware of what the code is, rather than having go back a few days or weeks and then and spending an awful lot more time trying to figure out what went wrong and then trying to unpick the Git history. So having this is a really good safety net that works really easily and just helps you again focus on developing the code. All right, well that's all I'm going to cover for this thing. I hope you found that useful, and we shall see you next time. Thank you very much. Bye bye. Cool.